Welcome to the deep dive. Today we're tackling a geometry puzzle that sounds simple but gets complicated fast.
The kissing number problem, right?
Exactly, like trying to figure out how many oranges you can pack around one central orange.
Uh-huh. So they're all touching the middle one, but not overlapping each other.
Yeah. And that basic idea, the max number of spheres touching a central one, it just goes kind of wild in higher dimensions.
It really does. It's deceptively simple in our world. 2 dimensions, like coins. 6 fit around 1.
Right. And 3 dimensions, like our oranges, that's 12. We know that one.
12. But beyond 3D, our intuition, well, it pretty much breaks down, and that's where it gets really interesting.
Okay, and that leads us to today's deep dive then, a specific development.
Yes, exactly. There's been a recent advancement specifically in the 11th dimension of this problem.
11 dimensions.
Okay.
And we're looking at work from AlphaEvolve.
That's right, AlphaEvolve. And what they've done is establish a new lower bound for the kissing number in 11D.
Okay, hold on. A lower bound. For you listening, what does that actually mean here?
It means they've managed to prove, concretely, that you can definitely fit at least a certain number of spheres around the central one.
Yeah,
So on an estimate, it's a guarantee of a minimum.
gotcha. A floor. So what is that number? What did they find for 11 dimensions?
They showed you can pack at least 593 outer spheres.
593.
Yep, 593 spheres,
Hmm.
all touching the central one without overlapping in 11-dimensional space.
Wow. Okay, going from 12 in 3D, which already feels kind of packed,
Right,
to a minimum of 593 in 11D.
right.
That's a huge lead. It's hard to even picture.
You can't really picture it. That's the whole point, isn't it? The gap between what we can intuitively grasp,
Yeah.
like the 6 coins or 12 oranges,
Yeah.
and the mathematical reality in these higher dimensions is just vast. 593 spheres, all kissing one in the middle. It really shows how limited our spatial intuition is.
So why is this problem actually interesting, beyond just being a weird geometry puzzle? Does it connect to other things?
Well, fundamentally, it's about packing density and how objects can be arranged. It touches on things like error-correcting codes, information theory. The geometry of high-dimensional spaces is just very different and has surprising connections. But the core geometric challenge itself is fascinating.
Okay. So the big takeaway here is AlphaEvolve proved you can definitely fit at least 593 spheres around 1 in the 11th dimension.
That's the key finding. They pushed that lower bound up significantly.
Right. It really makes you think.
It does. And maybe that's the final thought for you listening. What other seemingly simple geometric ideas become incredibly counterintuitive, almost alien, when we step outside our familiar 3 dimensions?
Like, how does adding just one more dimension change the rules so much?
Exactly. It sort of prompts you to ponder the nature of space itself, doesn't it? And how much complexity might be hiding just beyond our everyday perception, both in the universe and in, well, abstract math.